Okay, so limits to infinity are a little bit different, and we have a new strategy for them. So, the first step is the same as for regular limits. You plug it in, and usually what ends up happening, so several things can happen. Let's go over the easiest ones first. If, for example, you get a constant over infinity, then what that means is that the top is staying the same and then the bottom is getting bigger and bigger and bigger. So this is always going to equal to 0, and you can think of a really simple example, the function 1 over x, for example. The limit as x goes to infinity of this guy is equal to 0, right? Because it's got a horizontal asymptote there, right? So here, as x gets bigger and bigger and bigger, you're dividing 1 by a bigger and bigger number, so this guy is going to go towards 0. Okay. And that's important to note as well, that when you're looking for horizontal asymptotes, that's exactly what you do. You find the limit as x goes to infinity, or also negative infinity. Okay, now another thing that can happen is you can have infinity minus infinity, or you can have infinity over infinity. Now these are both indeterminate forms. This one, you want to, if this is the case, you want to turn it into a fraction. And this one, the second one, or the third one, I guess, here your basic strategy is going to be to divide top and bottom, so numerator and denominator, by x to the highest power. So here, if you have this second case, you basically turn it into a fraction so that you can do this one. And this is going to be our general strategy for finding limits. Let's do an example. Let's say you've got the limit as x goes to infinity of 5x minus 2x squared over 3x squared plus 7x minus 5. Okay, so if you plug in infinity, here you get infinity minus infinity squared, which is going to be negative infinity. We won't worry about the signs right now. And then the bottom is going to be 3 times infinity squared plus 7 times infinity minus 5. So this is also infinity. Okay. So infinity, the top is getting really big. Bottom's getting really big. So you have infinity over infinity, which is an indeterminate form. Okay, so then what I'm saying is divide the top and bottom by x raised to the highest power. Now the highest power out of all of these is 2. So what you're going to do is we're going to divide each one of these by x squared. So everything by x squared. So all of these guys we're going to divide by x squared. Okay, so then what I get is this guy is equal to the limit as x approaches infinity of 5 over x minus 2 over 3 plus 7 over x minus 5 over x squared. Okay. And so notice that if x is going to infinity, what's happening to each one of these guys? We just talked about this up here. If you have a constant over infinity, that guy's going to be going to 0. It's going to be getting super, super small. So these are going towards 0, approaching 0. So the entire fraction is approaching -2 over 3. So what you're saying is that the limit as x approaches infinity is -2/3. You don't mean that it's actually touching -2/3. You're just saying that that's what it's approaching. So that's the general strategy, and there are variations on that that make, some problems easier or harder than others. But this is the basic strategy. Let's do another one. Okay, so in this example, step 1, plug it in, right? So we plug in infinity on top, we get it's going to infinity over, this guy is also going to infinity. So infinity over infinity, this means more work. Now since we have a limit to infinity, our usual strategy is to divide by x to the highest power. Now, what's the highest power here? Well, you might be tempted to say, oh, well, it's 2. But actually, notice that you're getting the square root of x squared. So really, the highest power is simply x. But now here, all of this stuff is inside of the square root. So I can only divide by x on the outside. Okay. Now the top, you can simplify easily. The top is the limit as x approaches infinity of 5 minus 3 over x. Now on the bottom though, here you've got an interesting situation. Because to bring in the x inside of the square root, which is what you want to write x as the square root of x squared. But now these aren't really the same though. These are different. This guy, the square root of x squared, is actually the absolute value of x. So before you can turn this guy x into the square root of x squared, you have to be careful and you have to make sure you know where x is going. So because x is going to positive infinity, so because it's positive, then x is equal to the square root of x squared. Now, if x was negative, so this, you don't have to be concerned with this now, but if x was negative, I guess let me not do is, let's do was. If x was negative, then x would equal to negative square root of x squared, because otherwise they wouldn't be equal to each other. So you just have to be careful with these cases. So we'll do this one in a little bit. Now, so for this one though, I'm bringing the x inside as the square root, and let me rewrite this guy. Now inside it would be written as square root of x squared. So then these guys cancel, and so then this guy right here and this guy right here, these are both going towards 0. So then this is equal to, what's left over is simply 5 over the square root of 2. So 5 over the square root of 2. Okay, so in this next example, when we plug in infinity, notice we get negative infinity plus, here you have negative infinity squared plus 3 times negative infinity. So this whole inside right here is going towards infinity because this one is, I mean, a big number squared is much bigger than 3 times a number. So this whole thing is going to positive infinity. So although these are backwards, this is still infinity minus infinity, which is an indeterminate form. Now, the first thing you want to do, let me erase this, is you need to, in this case, we need to turn this into a fraction so that we can use our general strategy. So we're going to multiply top and bottom. To turn this into a fraction, we're going to multiply by the conjugate. So we're going to rationalize this guy. So we'll multiply by the conjugate, x minus the square root of x squared plus 3x. Okay, so then what this guy is equal to is the limit as x approaches infinity. Now the top, this is a difference of squares, so this is going to equal to x squared minus x squared plus 3x. And the bottom, I'm just going to leave it alone. So x minus the square root of x squared plus 3x. Okay, so here x squared minus x squared, those guys go away. And so then I'm simply left with the limit as x approaches infinity of negative 3x over x minus the square root of x squared plus 3x. Okay, so then what I want to do is here I'm going to divide top and bottom by x to the highest power, which is x. Now here though, sorry, I made a mistake. This is negative infinity. Sorry. Okay. Sorry about that. Okay, so we're going to negative infinity, but that doesn't change any of this. I just forgot to write it down. Now here though, when I divide this by x, remember I did this earlier. Let me do this over here on the side. You always want to check this out. So here, let me do a little bubble. So I want to turn x into the square root of x squared. The issue though is that because I'm going to negative infinity, this guy right here is negative, but this guy is always positive. So if I want to bring, so here I'm dividing the whole thing by x, if I want to bring this inside as square root of x squared to make these equal, I have to bring out a negative outside of here. So then, once I do that, I have the limit as x approaches negative infinity of negative 3x. So I'm just going to rewrite everything here. But I'm going to make the square root large, x squared plus 3x. Okay, so I'm going to divide this guy by x again, this guy by x again. Okay, and then this guy, I can divide it by x squared as long as I put a negative on the outside, which means that this negative is going to be changed to a positive. Okay, so you have to be really careful because it changes the answer of this one significantly. Now, here the x's cancel. Here the x's cancel. That's equal to the number 1. Here the x squareds cancel and you're left with the number 1. Here 1x cancels with one of these. So this guy right here is going towards 0. On the bottom, as x goes to negative infinity, the top is going to negative 3. On the bottom, you have the number 1 plus, be really careful here, this part right here is going to 0, but you still have a square root of 1 left over. So this is actually negative 3 over 2. Tricky, tricky, tricky.